excellent webinar to the Zoom thing just interrupted me. We have an excellent webinar today where we're going to be highlighting some of the work done by Massachusetts companies to implement toxic use reduction projects. This is a 90-minute webinar, and we're going to spend most of the time with our two companies, Boyd Corp and also New Method Plating. Although Jason Marshall, our lab director, will kick us off with a quick update on the TURI Hub grants for vacuum vapor degreasing. Let me just page forward. So as I said, we're going to start off today with a quick presentation by TURI, but then we're going to get really into the meat of these two projects. One with New Method Plating, we'll be hearing from co-president Nick Capalbo about their implementation of a vacuum vapor degreaser. And then we'll move to Boyd, where Ali Nori will be talking about their implementation of an aqueous degreaser. Unfortunately, we were supposed to hear from OTA today a little bit about their services. Jack Illingworth is unfortunately out sick, but we will be touching briefly on what OTA does and what they can offer to the Massachusetts companies. I just want to let everyone know we do have two more training events before the end of the year. We have a demo day, so an actual demonstration of the vacuum vapor degreaser at New Method Plating that you'll be hearing about in a few minutes. That's on December 3rd. And it's been pre-approved for 4 credits with Mass DEP. We also have a webinar on December 9th that's focused on how machine learning and AI can support toxic use reduction efforts and chemical hazard efforts. We think that'll be really interesting. It's very different from what we normally talk about. We highly encourage you all to come to one or both of these events. And you can always keep track of upcoming training events on our website, turi.org, or through our emails and newsletters. All right, with that, I am going to let Jason share.
All right, got the big screen?
Yes, looks
All
good.
right, it's nice of Agnes to let me share.
I'm on my webinar.
All right, so what I'm going to do is give you a quick overview of a EPA BIL funded project that we're just getting kicked off a year later, but still we're getting it underway and moving forward. So the staff from TURI that will be working on this is myself, as well as Alicia McCarthy, who's been around for a few years. Many of you know her. She does a lot of work in the lab around performance testing. She is trying to transition more to the sanitizing side, but she'll be helping out Alex and Amelia, who are the people that will be doing the cleaning performance in the lab, as well as doing site visits and collecting materials. And our research team is Gabrielle and Greg, who will be working on novel approaches to solvent mixtures that may not necessarily be off the shelf, that we have to kind of research and validate those. So the grant is looking at taking the work that we've done in Massachusetts around halogenated solvents and expanding it to New England. So we're partnering with New Hampshire, Connecticut, and Rhode Island, and identifying companies who may need help with assistance in moving away from the restrictions around TCE and soon to be other halogenated solvents. So the timeline, which is a year, like I said, a year later than we had hoped for or planned for, the fall right now is we're getting the project up and running. We're getting materials ordered and parts sent together. We're contacting companies in Massachusetts who are using TCE or PERC or methylene chloride for cleaning applications. We're still working with our partners outside of Massachusetts to identify companies in the surrounding states. We're holding webinars like this the next, on and off throughout the winter, talking about the project, how people could get involved. Alex and Amelia will be setting up site visits to collect materials to get testing started and going from there. So in the spring, we'll be trying to do preliminary testing. We're not expecting the machine to be ready until maybe late spring, early summer. But in the short term, we have the plans in place to bring in a benchtop version of a vacuum vapor degreaser, and we can do some preliminary testing and batch kind of smaller scale evaluations. And then during the summer, when the machine is up and running, we'll be able to do pilot testing and working with companies to identify process-specific parameters to make sure the machine works best for them, to showcase what they can do for the process and substituting for TCE. And then wrapping up after the year 2 is kind of putting out more reports like case studies, more webinars around the success stories, the challenges that we encountered along the way. So the main focus of the Hub grant is to review the chemistries, making sure that the solvents we're switching to are indeed safer than the current halogenated solvents, without sacrificing performance, and then keeping an eye on the financial impact of having to switch to a new process, a new machine. So the main thing is that what's new for us is that we'll actually have a full-size working vacuum vapor degreaser here at the TURI Labs to be able to run and do testing for companies on their specific soils, under their, finding the optimum conditions, and so that they don't have to worry about taking their process offline to be able to do this evaluation of the alternatives. And so we hope to have money available to provide some incentives to participate, either traveling to TURI or sending their parts to us, and working together and to do the documentation and the reports at the end. So we talked about the overall safety performance. This is an example of the modified alcohols. There's a few that are out there from Dow Clean and Metal Knox. The middle 2 columns are the active ingredients in both those formulations, and you can see how they stack up against TCE and NPB. So you can see there's a lot of areas of concern for TCE and N-propyl bromide, same for methylene chloride and PERC. So we're showcasing that these are, safer chemistries. As I had mentioned, in some situations, we may not be able to find the right chemistry that's off the shelf. And so with our green chemistry staff and research people, we'll be looking into novel mixtures and looking at new azeotropes, co-solvents, bisolvents. And this has all been nice and in theory until yesterday, when this picture, the stock picture, could be replaced with our happy green chemist. And there you see the rotovap machine that's going to simulate the vacuum vapor degreasing. It took him about 9 minutes to run down the hall, whip open the box, and set things up and say, I'm ready to go, let's get started. So he's ready to go. So we're looking to expand the success we've had in Massachusetts around the halogenated solvents replacement, strengthening our relationships with other P2 organizations in New England, and working with these companies to help them find safer alternatives. And with that, we want to hear from you guys down the road about what your concerns are, what your needs are, because our work is not done in a vacuum, it's done in a vacuum vapor degreaser. And with that, I'll end my dad jokes.
Thank you so much, Jason. Excellent dad joke at the end. I just want to open it up. Does anyone have any questions about what Jason just presented and on the opportunities you have with TURI?
I actually do, and I'm not seeing where I can raise my hand. I'm sorry for being rude.
That's okay.
Just stepping in. So, Jason, this is very interesting, and I just wanted to bring up Transene Company. That I don't want to be a sales guy here, but we manufacture alternatives to the halogenated solvents that are currently being used in degreasing applications. So I'd love to interact with you, probably offline and not bore everybody, but provide some information. We'd be happy to participate, submit materials for testing, and we'd also be it could be a Massachusetts-based manufacturing site for developing alternatives if we find that there's some additive or other modification that's needed. We'd be ready and eager to work with you.
Great, that sounds excellent.
So I see your email, jason._marshall at you. Yep. So I'll get in touch with you after the webinar today.
Sounds good.
All right, thank you.
Excellent. Does anyone else have any questions, comments, want to get involved?
Hi, morning. I'm Jim Salenza from Rikers, Rhode Island. And for a number of years, we worked with environmental management here, solving the substitution issues. And we certainly are very interested to see that the hub is now proposed to include out of Massachusetts. opportunity. So if you have a brief write-up about the new Solvent Hub policy,
Yep.
you send it out to me, and I can circulate it to some of the folks here who have been involved in
Great.
the
Yeah,
past.
that was part of the preliminary work that we're doing. That's the nitty gritty
Right,
stuff. Yeah, the brochures and stuff. And so we have something that we can get out to people on the
right,
call. I
right.
have
Thank
to
you.
make sure it's finalized by our outreach person, but I think it's pretty close. So within a week or two, we should be able to send that out to people.
Excellent. Thank you. Any other questions, comments? Feel free to email Jason after the fact if you think of anything. All right. Shall we move on to Nick? I will let you take the stage.
Okay. Give me 1 second.
Yeah, no worries. So you'll just want to start the slideshow so that we can see the
Yeah.
slides a little bit bigger. I know we were just on right before this call, we were all saying, most of us are a Teams organization, and every time we have to get on Zoom, it's like relearning
Yeah.
everything. So.
Oh. From beginning, correct?
Mm-hmm.
Nick, I sometimes find it easier to use the little icon on the bottom right of your screen to click on the slideshow. Bottom right, bottom.
It's all right.
It's all right. Do you see the little screen icon next to the sound bar in the bottom right? There you go. That guy there.
There she is. Okay. Hopefully. Oh, I gotta start from the beginning. So sorry.
Oh.
Oops. There we go. Okay.
Perfect.
Sorry
All right,
about
there
that.
we go.
Finally got there. Okay. Thank you very much for having me speak today. Again, my name is Nicholas Capalbo. I am co-president of New Method Plating in Worcester, Massachusetts. The folks at TURI basically asked me to kind of speak about our, I would say it's a process, and it's been an adventure, and it's been an educational process of upgrading from TCE or trichloroethylene to alcohol-based solvent. It has been a timely process, but we do have some definite positive results, which I'm kind of touch base. And again, that was I was asked to speak to explain our procedure and how it has come to be. That was really basically my presentation, is the whole experience from making this decision to where we're at now. So, just a quick little blurb about us. We were established in 1931 by my grandfather. We are third generation business, my brother Chris and I. I threw this in just kind of as a important tidbit on trichloroethylene. We have been using trichloroethylene for well over 50 plus years. And it's always kind of a situation with, I think, a lot of platers and chemical users. If it's not broke, don't fix it. It's a great product. It has always done the job. We've always had successful cleaning, but ultimately is on the endangered list. And we know that there are some health hazards and there are some concerns. So it was always one of those things like, yes, we need to address this, but we knew it was not going to be a quick transition when we're having great results with something. To try and switch this a different chemistry, we were concerned with quality issues, production issues, et cetera, and so forth. So it has been a lengthy process to really reconfirm that we're doing the right thing here. We specialize in production plating. We primarily do zinc, cadmium plating, and nickel plating here. We do vapor degreasing as a side business, and we also do it as a primary for parts cleaning. So that's just a little tidbit about us. I know Turi had kind of give me some, points of discussion for the webinar. One of the, motivation, why did we do this? Okay. Primary reason was obviously one of the biggest issues is our aging equipment. We had equipment that was definitely failing. We were having production issues, maintenance issues, some quality issues. Obviously, the threat of the banning of the trichloroethylene, which everybody knows, everybody's pretty much why they're logged on today. This is a known thing. It's not a question that it's going to happen. It's a matter of when. Obviously, the chemical hazard of is a big issue. I'm going to just say TCE to make life easier. Everybody knows obviously what we're talking about. So I'm just going to say TCE. One of the more interesting parts of this that has come as we are officially out of TCE completely here is waste removal costs. And I will touch into that in a couple of my slides a little bit, which are completely astounding. What the waste removal costs have gone up tremendously, as everybody does know, the waste costs have gone up tremendously, specifically, and I will touch base on that. Energy and maintenance reduction was a key factor too. We had two machines running in a high pressure steam boiler. There's a lot of maintenance, there's a lot of electricity, and we were obviously hoping to cut our electric bill down. Absolutely. We definitely use a lot of power in a plating industry. Cutting down that usage was a big motivation. So that's just a quick little, I throw up a couple, just a little before and afters. These are just some basic screws, before and after screws on the left side. We had just a light machining oil on them. You can see before and after. Again, we do two different processes with our vapor degreasing. It is for surface preparation prior to plating. And that's basically clean off burrs or heavy contaminant oils that the caustic and various cleaners will not take off. And the other part of our business is strictly vapor degreasing. We have customers that send in products to be vapor degreased and sent back out. And that's two different aspects of the machine. One point that I'd like to make is that for us specifically, we are a job shop. We don't know what's coming in. We have to be able to adapt at all different types of products that could come in one time, or it could be years on end coming in. We don't know. So finding a machine and chemistries to adapt to that was a major concern for us. Quick little rundown. What basic materials that we do process? Steel, some die cast, brass, stainless steel, and aluminum. That's kind of the basic materials that we handle here for either surface prep or final production for cleaning. Either way, there is an importance for oil removal. It is very key, obviously, for plating. If you have terrible buildup, oil contamination, buildup on the parts, you're going to have production issues, flaking, etc., and so forth. And the other aspect is that for a lot of the finished jobs, a lot of the parts of machining blind holes. And there's a lot of the customers request, they want that cleaned out. They want those burrs and drillings and shavings. They want all that removed for either final assembly, powder coating, etc., and so forth. So that was a major concern that we made sure, and with the TCE, we was always very successful at really doing a pretty well job at getting all that removal. So we were concerned, is this modified alcohol? Is it really going to handle it? Is it going to, where are we going to be at? Are we going to start facing production issues with changing over? And again, I kind of touched on this, but being a job shop, again, we have to deal with, very odd jobs that come in, cylinders, plugs, pieces, you name it. It can be screws, it can be round parts that can't be banged up. So that was a big consideration for upgrading our equipment. Okay, this gives just a quick little before and after of our equipment. The machines on the left are, you could say, our old equipment. There were two machines there. The new machine is just one, which we're happy, and they take up about the same amount of floor space. Um, the new machine is an ILSA manufacturing. It's an IK40E. It's a vacuum degreaser, metal cleaning machine. Um, the chemistry that we ended up buying and purchasing after some research is the Dow Clean 1601 modified fluid modified alcohol based solvent. I will tell you the machine is manufactured in Italy. The representative is through Alliance Manufacturing here in the United States. I can give you some more information on that as well as we go through the presentation. One nice thing on this, obviously, we're going from two pieces of machinery that need twice as amount to one piece of machinery that has everything encompassing. So we were very happy to have one machine to handle all of our production. So it was very well executed as far as that going from two to one. We've been very happy with that, maintenance reduction. So they asked me to talk a little bit about implementation experience. So as far as the chemistries, there are a wide amount of chemistries, and I will say there's chemistries with variations in them that we found. The biggest thing that I can tell you is that reaching out to your suppliers, talk to people, get some information as far as, hey, can we do, I do this type of work. I'm looking for this type of results. We run this type of production. Chemical suppliers usually can point you in the right direction. Picking out the right chemistries is very important. Trialing is, we did that. We made use of TURI. They did some trial samples for us. A lot of the chemical suppliers are willing to send you. We have one supplier actually send us a unit, a complete machine to test out. Trying to visit places, customers, etc., so forth. There are some resources out there to make use to try it out. It's important to get your SDS sheets on your chemistries, see what's in them, so what's available, make sure there's no issues for what type of production you are running. Equipment selection is a big one. There are a lot of manufacturers out there. There's a lot of equipment. There's a lot of different sizes, capacities. You do have to do a little bit of homework, which I did, as far as how much work you need an hour, how much production you plan a week, how many shifts, hours per day, etc., and so forth. So there's a lot. Picking out the right piece of machinery is I think, next to the chemistries, is very important, because that is essential to making this modified alcohol product work correctly. It's really having the right equipment. I know this particular manufacturer, I'm speaking based on our experience, was very willing to work with us, customize actually the machine height down because it would not fit in the building, which was a big issue. They were very accommodating, excuse me, to shrink the height of the machine down, and modify the machine to make it work for us, which was great. They answered a lot of questions. Have a lot of questions out. If you're just starting out in a vacuum degreasing business, if you're just establishing that, it can be a little bit of a shell shock from an open top or a aqueous cleaner. It is a big change. There's a little bit of different science to it. Equipment delivery. Yes, these things are not off the shelf. It's not like going to buy a car or, going buying something at Home Depot. This is a custom built piece of machinery. They come from various parts of the country. They do take time. This was about a year, about a year wait from purchase order to delivery, or just under a year. So don't wait on this. This is something, if you are at a point where, which is where, again, for us, our machinery was at the point of failure. We had just crossed the line of ordering it just in time to get us to take the next leap and remove the old machinery, put the new machinery in, back in service. We were just there. So that's one thing I could like to tell you as far as implementation is don't wait. If you are at a point on it, do your research now because there's a lot of information. There's a lot of considerations to purchasing a new machine. Again, kind of already touching base on considerations. That's kind of where I'm at. Again, reach out to your to TURI. They were very good. They did a lot of sampling for me. We basically, I've started this project probably, I would say, a solid 5 years ago, trying to put some materials aside, reach out to chemical suppliers. I think it has been a process. I viewed different manufacturers. I know I did this particular machinery. The sales rep was nice enough to let me go to a customer and actually go see the equipment. I think that's very important. I think that's a great if you have that opportunity to go physically look at the equipment. Obviously, the chemistries. Luckily, the machinery that I saw, the chemistries happened to be the same that we were interested in, so that made life a lot simpler. But going to actually see the machinery, open the doors, ask questions of the current person who is operating it is very important. It's a big decision. The chemical suppliers, again, they will reach out. There was a fairly lengthy determination of kind of going back and forth about the types of oils we were using or receiving, chlorinated oils, et cetera, and so forth. Again, repeating as a job shop, it was very tough to limit down to say, yes, we're going to receive a certain type of oil. Some of our products come from overseas. It is very difficult to narrow down exactly what type of oils. So there has to be definitely some feedback, and most chemical suppliers will ask you that to say, what types of oils are you using? And I said, I don't know. It's very tough to say because we don't know what we're getting in. We had a rough idea of the types of oils, some machining oils, some are very heavy. So having that information or the best to make an educated decision, it was a big part of this, and I wanted to kind of share that because I figured, oh, degreasing is degreasing. What is the big difference? But there is consideration, especially when it comes to with the modified alcohols. There was testing, which was actually in my previous slide. There is a testing procedure which we conduct once a week. We draw a sample out of the machine. The lab technician will test it, and there's two different stabilizers for the system. And luckily, we have not had any additions made, so it's been working. It's been very stable, which is great. So there are a couple different stabilizer systems that are available along with a test kit that must be purchased to test the solvent out. I'm going to quickly kind of just jump into the waste removal costs. So took me a little bit of punching around on a calculator, and that number is legitimate. I came up with 159% increase on hazardous waste removal. That is for a single drum of oil or oil mixed with trichloroethylene. My cost went up almost to $1,650 for the last drum of that's just oil and tri. That is astronomical. That is crazy. Obviously, we all know waste hauling is very unpredictable nowadays. The prices vary. There's a lot of surcharges. Obviously, I'm sure like most platers and everybody in hazardous waste hauling, you try to maximize the most you can for each pickup because there is such a cost associated with it. I was very happy to know that drum was the last drum. We have no more left, and I am happy we have closed the door on it. But that is a real consideration for everybody. I wanted to share that the waste hauling costs for the tri has gone up considerably, crazy amount. Obviously, alternatives compatible, the results have been great. We have definitely have had increased quality. The work was to come out clean, but now it's coming out shiny, specifically on some stainless steel parts and stuff like that. So it really has been, as far as that, a very useful to us for when production gets busy. We want to get this product in, we want to get it out, and most of the customers need these products back quick. They want a quick turnaround, and that's been a key part of this whole thing. Quickly on machine operation. The machine itself is obviously computerized, touchscreen user interface. Very simple. One thing I will say on it is you kind of can't mess it up. They have a lot of safeties. Again, speaking about the ILSA unit that I purchased. It has parameters in there for startup. You start the machine up in the morning, it will tell you when it's ready to operate. When you put the work in, you start a cycle. The cycle will compensate for drying time. It will compensate for heat. It'll compensate for cleanliness. So there is no variance that, oh, the work is coming out wet or not dry, or it should be cleaner. With it having a significant size vacuum system on it, it draws out, and it will continue to dry until it has evacuated all product from the machine. So in the couple of months, we have not added anything. The gentleman, when we started the machine, when I said, oh, we put 2 drums in here, and he said, I said, oh, I should get some more. He says, you won't need it. And I think he's right. As of now, we have not had to add any solvent. We have obviously drained out roughly 1 gallon to 2 gallons a month of waste oil. That waste oil has now been classified and is going to cost me $160 a month for a drum of just oil, because there's no hazard with this anymore. So put that in a quick perspective to everybody. I just got the price on that a couple of days ago. I almost fell out of my chair. I was shocked. And the other nice thing on the machine, the minimal training required. It, again, with it being fully automated, we can have any of the guys quickly show them, yep, door opens, closes. It really is automated. When the load is completed, the machine turns green light, you're good to go. One of the things that's interesting on it, as the machine heats up, it continues to go a little faster. So as the morning cycle, it takes a little longer, but again, it's all part of the automation of the machine. There are, I think, 30, maybe 20 to 30 different temperature controls in it that is constantly checking. And that's nice. It's nice knowing that the product is staying in the machine. I don't have to babysit it. I don't have to sit there being concerned if the product's going to come out wet or not clean. Just some kind of quick results. Again, July 23rd was our initial startup. So we're not exactly a year into this operation, but we're several months in. So far, so good. Again, I already touched on this, that there have been no chemical additions made to the machine. Maintenance in lab, again, the machine will remind you after so many cycles per your setting to drain the oil. It will tell you when the water separator has to be drained. It will tell you when it's time to do a lab testing. So again, I think there's something to be said about that, especially something as a degreasing, where it's an automated machine. You're kind of putting the product in, you start it, you kind of walk away. This is a lot of checkpoints to remind you to do what has to be done. It'll tell you like, hey, it's time to do something. With the fully automated, we definitely have seen reduced cycle times compared to our old machine. And the old machine, one of the downfalls on the older technology is that the machine would run based on time. So if it was programmed to wash for 2 minutes, it was programmed to evacuate for 30 seconds, it was programmed to dry for 6 minutes, and then it was done. That never allowed for 100% clean parts. Whereas now, again, the machine's doing all the guesswork. Again, energy reduction, I've spoken this already, but we're going from one machine versus 2 in a 180 psi electric steam boil, which was a huge draw on electricity. We have seen a drastic increase in reduction in time. The machine has really not been running 5 days a week based on we're getting tremendous results with our production. So it's based on an average 40-hour work week. I would say we're probably only running it about 30 hours a week, I would say. The machine is definitely quicker for the production wise. And the last kind of tidbit on this I'd like to touch on is we have definitely have received customer feedback. We had told some of our customers we were implementing a new chemistry, and not necessarily we wanted to get kind of a blind feedback. So we wanted to say, okay, let's see what we get for feedback. We said, yep, we're making a change to our cleaning system. And then we got some drastic feedback. We wanted to get some, some actual feedback from our customers, saying there was much better cleanliness, less, residue, et cetera, and so forth. So that has been great. That has been a really great advantage to this whole process of getting this machine completed and installed and physically in the building. So that's it. That's kind of my rough. Has that been about 20 minutes? I didn't start my timer.
No, this is excellent. Thank you so much for sharing all of that. Sure. We had a lot of eager questions in the chat. Pam, would you mind reading some of them out?
Yeah, sure. Yeah, no problem. So Nick, to your last point about working with customers, Chris asks if you had to notify customers ahead of time and whether there were any issues there.
No, none of our customers had any issues. We explained, obviously, we approached it that we were eliminating a hazardous chemical. They all knew we use TCE. And we said we are going to a greener product. And certainly we had no pushback from any of our customers. They were more than willing and very happy to hear that. They said, great. Hey, so that sounds good. We'll keep an eye out for it. And it was nothing but really positive feedback. And it was QC feedback from us as well, as far as examining parts. We could tell right away that stuff was coming out better and cleanlier than before. So no, it was all great feedback from our customers. Definitely. Yeah.
Great. John was asking whether or not the ILSA unit is able to recover or recycle the modified alcohol. How does that work?
Yes. Okay. So as far as that goes, yes, it is recovered. Basic principle of a vacuum degreaser, specifically this machine, you have 2 tanks and a still. The still is where the dirty product is. You have 2 clean tanks. Process starts, you put your work in, it sprays, it will spin. There's a lot of different variations on speed of the rotation. You can do tilt, you can do stationary, so it doesn't tilt in case you have delicate parts. So it will go through its cycle. At the end of the cleaning cycle, it will go into a dry, it will go into a vacuum. It pulls all that solvent back into the still, where the still is basically blanketed with electric heating coils. And as it boils that out, it will boil and return all that solvent back into the clean chamber, and then the oil remains in the still. So then at that point, once a month for us, and again, everybody, depending on your workload, you might have to do that more often. Once a month, we're getting about 1 gallon or 2 of the waste, but all product does return back into the machine. And we have not found wet parts or any solvent in the waste oil as of now. So
yeah, it's really terrific. To your point about the different kinds of parts that go in there, yes. Bill asked a question which I think might be a little tongue-in-cheek, but the question is, is there a length limit or a size limit of the parts that you can handle in this machine? He's wondering if we can do a 58 Cadillac front bumper.
Yes. No. Okay. We'll touch base on that.
Sorry, Nick. I I've never been in your shop, so I don't know what size parts you guys can. What is the old system versus new? Thank you.
Yeah, no problem. No, okay, that's an interesting point. I probably should have put a slide of the baskets in, but I didn't. So the baskets that we're using currently are about 28 to 30 inches long by about 16 inches wide. One of the changes that has been made, and it's actually worked out very well. Our old machine, you had to double stack both baskets on top of each other. You put one in, it would spin in that, and then you'd have two baskets. The ILSA machine, it operates with the same two baskets. Actually, they modified the chamber to work with my existing baskets. So now we have, I think, a roughly 40-inch long capacity to do both baskets. So I think it might even be bigger than that. You caught me off guard with that. It might be a little longer than that, but nonetheless. So it's roughly about 40 to 45 inches, I think, long. So both baskets slide in all at once, the door shuts, and then the process begins. I know they manufacture up to 4, maybe 6 baskets. I think Jim Timler is online. I think he was going to log in, but they manufacture many different size machines for capacities. That I can tell you, I don't know. But for us, it's probably 40 to 45, 42, 45 inches long capacity, which is great. So that actually is an increase for us for longer jobs that could come in. That has been an increase from our 20 to 30 inch baskets. So 25-inch baskets.
Yeah. Hey, Nick, thanks for throwing my name in there. I can tell you, you're correct. The machines are built around the customer's production. We're not a production machine. We support production, so we have to keep up with whatever those needs are. And Nick is correct. Chambers to accept multiple baskets. Sometimes it's large baskets. Sometimes it's a basket. It really just depends on the process we're working with.
Yeah.
Thanks. And to that point, New Method Plating is opening up their doors and inviting people to come and see the equipment in process. So I put a link to the registration for that demonstration event on December 3rd in Worcester. So if you can join us in the morning on December 3rd in Worcester, Massachusetts, you're welcome to register. We'd love to have people really see it and ask questions in real time.
Yes, no, definitely. One of those things that it's nice to see it. We're hoping to put some work aside, some actual production work to kind of see what actually kind of show what the capacities are. The backside of this thing is quite intimidating. I know the folks from TURI there, when they bring people on the back of the machine, they their eyes roll open. But there is a lot of moving parts to it. But it's also very impressive, as far as the construction goes. So that's,
you'll be showing us, how it actually functions and hopefully getting the really gunky stuff. I actually had a question I wanted to follow up on your comment about the different oils that you get parts in with a number of different kinds of oils. Was there any oil or grease that you found that this equipment does not work well for?
I gotta be honest, no. I have not. We have not thrown anything at this so far that it has not cleaned. It's we keep throwing stuff in I don't know, maybe it's not, and it comes out. So no, we have not experienced any issues so far, in all honesty. Not saying we might not encounter or have to increase the cycle times. Absolutely. And that is a consideration. We have the machine arrived with basic parameters and steps. I think the machine can hold up to 32 different programs. We're basically using about 6, and you can program whatever your needs are. Like I said, one of the nice things in our other machinery was either spin or no. You can have it so the barrel tilts back and forth. We do have a low speed, so that the machine, if we have threaded objects, like we do a lot of stainless steel with threads, delicate brass that you don't want danged up, you can slow the RPM down to the drive so it goes nice and slow. We've seen tremendous results with that from customers, regarding any damages or bangs and nothing. So it has worked out very well as far as what we've put in the machine so far. Yes, very well.
Cool.
To follow up on that, Pam, they're another company we've been working with. They had some issues with the modified alcohol not working on a particular heavier soil. Plus, it also has some interactions with some of the nickel metal. And so we worked with Isla and Jim from Alliance to try out one of the other solvents that can be used in the machines. And so there are hydrocarbon-based solvents that can be used in similar machines that address those issues. So if it's not the modified alcohols, it can be the hydrocarbons. And if it's not either of those, that's where our research is going to help fill holes as well. So.
Yes, absolutely.
That's great. And maybe just one last question, Agnes, if we have time. And following up on your comment about the modified alcohol. So Bill had asked, what do we mean by modified alcohol? And you explained it in the chat, Jason, but if you wouldn't mind just kind of speaking to that, that would be helpful.
Yeah, so the modified alcohols are essentially glycol ethers, and they're the main component in the Dow Clean and the Metal Knox are the Dowanol PNBGE. I have cast numbers in my presentation that if you really wanted to do a deeper dive to take a look at those, I know that John Rashko from OTA was asking about those as well. Take a look at those. If you still have some questions about them, send me an email and we can discuss the pros and cons of the solvents and making sure we compare them to what they're replacing to make sure that we're moving in the right direction.
Great. Thank you.
Well, thank you so much, Nick, for sharing all of these learnings. We've talked a few times now, and every single time I talk to you, I feel like I learned something new. So this was an excellent presentation. Thank you folks in the chat for sending questions. If you have further questions, please just reach out to the training team. We'll connect you. All right, shifting gears a little bit, Ali, I will give you the stage.
All right, thank you very much. It was a nice presentation, Nick, and very good experience. I guess I have more questions, but we'll deal with that on emails. So let me get my presentation. Give me 1 second.
While Ollie's doing that, I just want to point out, Jim Salenza also had a question about connecting toxic use reduction to greenhouse gas emissions, and so we're gonna check in with him offline and see about taking care of that.
Yeah, that's a very good question, and one that's definitely a goal of ours to work on quantifying, but yeah, definitely a little bit longer than the little chat box will allow us to address, but thank you for that question.
All right, so I need to share. So what is that share thing? Share presentation. Okay.
All right, you just need to start the slideshow.
Yes. Give me 1 second. Okay.
So right now we're seeing your desktop. Just giving you a heads up.
Yes, I would like to. Is my screen shared or not yet?
Yes, you're sharing your screen. So yes, there we go. Perfect. All right, everyone.
All right.
Go ahead.
Yes. So for our experience, we also were using GCE. We were using actually two unit, two different department. One department we went to a different vapor, not TCE, but a different vapor system, and in the department where I work, which is tube and fin, we used a Aqueous system. So the goal was not financial, it was mainly because TCE will not be anymore allowed in the United States to be used. So that was our the main reason behind us switching to the aqueous system. So again, as I say, it was a safety requirement to replace the trichloroethylene TCE degreasing system. We know the regulation will prohibit the manufacture, processing, and distribution of TCE and any material that contain TCEs. So the decision was pretty much through also to replace the TCE degreasing system with an aqueous, and I was not involved in the first phase, which is designing the TCE, because it was designed between our engineers and the manufacturing engineer. It was a collaborative work. We know what we needed, so we tell them how it's going to look like. So we picked a company named Bramco in New York, and they have a great deal of experience in the aqueous system, and we pretty much let them design our system based on our requirement. So the aqueous process is very simple. It's something that a lot of industrial places have been using it for a long time, and it's specific. So every business or every field or any field that will need to adapt the system to their need and not the opposite. And it's easy adaptable compared to our system. So our company, we make a heat system, cooling system with heat exchanger is a main part of our production. We work with aerospace and defense in the North America and Europe. Our core business is cooling system design and manufacturing primary heat exchangers. So our first section of business deals with vacuum brazing. Vacuum brazing is a highly the requirements are very, very tight as far as cleaning. So any part that you put in oven has to be cleaned to a vacuum brazing system standard, which is very, very high. So in that one we picked a vapor system. We cannot use aqueous, so we purchased a vacuum. We replaced the TCE. We used to use TCE. We replaced that with a vacuum. A vapor system, similar to the one that the previous presenter was talking about, but it's not a vacuum. It's just a vapor. And the other department, which is the fin, the tube and fin, that's the one we are using the aqueous system for. So pretty much in the aqueous system, this is what we clean most of the time. It's just heat exchanger like that. The material it can be copper, aluminum, hastelloy, stainless steel, you name it. So the chemical has to be compatible with the material, and also it has to work with the oil. Its aqueous system is not alcoholic based, so it just water and chemicals. So it has its own requirement, and the tests are slightly different than any vapor system. I will explain that in the slide that comes. So now for our the standard, the Boyd standard as far as cleaning goes. So we have some key parameter to cleaning process. before cleaning, we do a visual inspection, and after cleaning, always to see. We don't do it for all part, but we have a procedure that every new batch or every new type of part, you need to inspect the part before, see if there is any solid, because the Aqueous does not clean any solid stuff. It has to be liquid or grease or something that is removable by Aqueous system. We do also to test if the part is clean or not. We do heating inspection. We bake the part, or we just use the torch, acetylene, or the propane torch, and see the smoke. If there is any smoke, even if it's low, then the system is not cleaning. Of course, we use a microscope to check. We inspect using a microscope, low power microscope. We do a whipping inspection for tubing, specifically for tubing. We go all the way to some tubing are 24-inch, so we have to go all the way inside to the elbow, because most of them are hairpin. We do water break test. We have the set. We do the damping test. And we also a non-volatile residue inspection. We had this problem, and we actually changed the oil because of that. We do some surface UV fluorescent detection. That's mainly when customer require it. We don't do it all the time, but sometimes customer require pictures of that. And the last one, which is the pretty much one of the most important tests we do for the part, we do paint bound test, which actually it's done in a third party, not in our plant. We have a partner or a provider that paints our part, and they do that for us. Some other conservation include chemical cost. Also, we have been saving a lot switching from GCE to Aqueous in a lot of ways. The cost of the chemical itself, and the cost of disposal, how we get rid of the chemical was a messy operation, just because the regulation was so tight here, and everything was costly, and the machine was old. We were consuming a lot. Everything was telling us to change the machine, and we finally did that. The labor cost also is a factor. Pretty much no change on that. It's the same people are doing the same thing for the same length of time. And operational cost, it's better with the Aqueous. I would say we're saving 50%, because all systems have an AC system that is old, and we used more power before than now. So this is the system. This is the Ramco system we bought. The Ramco system is a modular system that has a wash tank, that has a rinse tank, and that has a dryer at the end. So we wash the part in a mixed water and chemical, or soap. We prefer calling it soap, because it is very equivalent to soap. And then after that, it goes to the second tank, which is the rinse tank. Those tanks, of course, they are heated to 140 Fahrenheit, and then it goes to the dryer. So the wash tank is a double wall isolated stainless steel cover tank, 36 by 36 by 40. It's equipped with a reciprocating platform. The platforms actually move up and down for agitation. It's heated. You can heat it to 200 degrees. It have two sonic transducer. We use sonic. We cannot clean without sonic, because we have fins, and fins are very close, and you need to vibrate that somehow, or you need to get those little vacuum. The sonic creates those pretty much as it's like you're doing a sandblasting, but with a vacuum, a little vacuum, tiny. Um, I would say particle. It's like particle, but it's a vacuum. When it touches the surface, it almost like explodes, and it actually mechanically remove the oil from the surface. It's a great tool. And we have turbojet. We actually mechanically force the water to go through the part from the bottom and from the sides, lateral and bottom. And also we have a skimmer. The liquid is skimmed continuously to get the oil out from the surface. And then the tank is filled. We have a filled pipe and a drain pour. And we have a filtration system, very standard filtration system to filter the liquid. So our liquid is always clean. The soil is taken out. Any solid stuff that goes to the pump is filtered, and the water that is skimmed goes to a skimmer, and any oil that's in it will be taken out. And we don't recover a lot of oil because our part doesn't have a lot of oil. So we whatever we recover, it's taken care of within the company rules. So the second tank is a rinse tank. It's the same design, same size. It's heated. We have agitation. It goes up and down. The platform go up and down. We have turbo, but doesn't have sonic. It doesn't need sonic on the rinse. And it's the skimmer. We don't have a skimmer, but we do have a gravity skimmer, which is we leave the water input a lower level of about 1 gallon per minute or half gallon per minute, and that extra water always skim the top and take the oil off. And then the dryer is just a forced air, hot air dryer that dries up the pot. And all these is managed by a PLC system. You can program anything you want, like time-wise, program the time on the agitation, the time on the turbo, the sonic. So you create your recipe based on the part shape, the part size, based on the material, based on we have a lot of variables to play with, and it allows us to create recipe that works for each part. So now the concentration. One of the main variable or parameter is the concentration of the chemical. So when we start, we were using one chemical that was giving us causing a powder deposit on our copper and galvanized pieces. So we decided to change it, and we changed that. Now we're using a different chemical. It's from Kaizen, made by Kaizen, and it doesn't have it doesn't cause any deposit, even though it is made it's a solution that is made out of powder, but it does not cause the part to attract that powder and get the powder all over the place. So it's cleaner as far as powder, and we're working with it. The concentration for the Kaizen is we check it by checking the conductivity, and then using the shot we can tell the concentration. So the concentration usually it's between 3 and 6. That's normal. Above 6, it's too much chemical, too much soap. We stay between 4 and 5. That's what, and it's cleaning pretty good. Between 4 or 5, it's pretty good. This is the old style. We used to the first chemical we used to do titration to actually know the concentration. The Kaizen does not need titration. We have to measure the conductivity, and even with the old fluid, the conductivity does not change because all the soil are not conductive, so they don't change the conductivity. So when you measure the conductivity after a month of use, if you're having a 4 millisiemens, that's a 4 millisiemens. The soil, they do not change the conductivity, which is good. So so the when I started the system, it was very difficult for us to clean part for a lot of reason. The phase 1 testing machine, we verify the machine. We start verifying the machine. Everything works, and the manufacturer help us a lot on that. They give us a 24 hours pretty much. Anytime we call them, they are there trying to start the machine. We start it up, everything runs fine, and then the problem is the cleaning was failing. We were not cleaning. The machine, when we got it with a basket that we designed, and the first design was done without knowledge of the problems we had after that. We just design a basket and think, okay, this is the way we're gonna use it. It's a basket with an incline, so we put our pieces incline on one side to in one direction, and then we were hoping that liquid gonna go inside the tubing and then clean. It didn't work. Nothing worked at that time. We were not cleaning the inside, the outside, and again, it's aqueous. Remember, it's not alcohol. It's the density is different. Everything, water is the surface tension. The surface tension needed is different. So everything was against what we were doing. So at this stage, I didn't have a complete understanding of the equation solution specification. That was my main problem. I conducted more testing with a series of combination of temperature and concentration. No progress. So what happened then? I had to come up with something. So the phase 2, I modified the detergent. That's what I just said. We changed the detergent, and we did tests at different temperature, different concentration, using the same basket. I did not redesign the basket. At that point, I didn't know that the basket was a problem too. So we noticed some improvement. No powder. The second chemical was fine. And this is pretty much the value I was talking about. If we stay between 4 and 5% at 150 Fahrenheit or 140 Fahrenheit, no powder, no problem. So no progress made on oil cleaning. We still have oil on our part. So then the phase 3, we were like, okay, let's talk about the oil now. We will start testing our oils. Emulsification, is the emulsification happening? Is the oil actually, the density of the oil, is it right for water system? And then we find out that we have had to get rid of 3 different oil because they were not compatible with the aqueous system. Some of them were soluble. Soluble oil is not good for our application. Some of the oil are heavier than the mix, and they actually stay on the bottom. So we actually changed 3 different oil to one oil that we are using. We consulted a specialist in oil, a manufacturer that we have been working with for a long time, and they sent us a different one oil that we are using in all our fin press and our punch press machine. And that oil, the new oil, is not soluble. The emulsification is perfect. It separates fast from the mix. It goes up, it's float, and then we can skim it, because any oil that does not float is not compatible. It has to float to be skimmed out from the tank. So when we changed the oil, that was the best result as far as emulsification goes. We were not contaminating our tank. The tank will stay clean, and the oil, we can see the oil, we can skim the oil, but we still not able to clean the inside of the tubing, because remember, we make heat exchanger, and with heat exchanger we have tubing, and they are fin tubing, which would mean the tube have an elbow at the end. So if you put it incline in one direction, it may fill and not drain. If the other direction, it will not fill. It may drain, but it will not fill completely. So you will have oil inside. This is a picture of a good oil. A good oil should look like that. This is a mix, and this is a good oil. This is a bad oil. This is the M4. This is one of the heaviest oil we have. We use in expanding tubing, fin heat exchanger expanding, and it stays on the bottom. This is a soluble oil, so we get rid of this, and we only kept this. Now the fourth phase, which is a basket, then went back to the basket. And so after eliminating all the oil problem and the chemical problem, now the basket has to be redesigned. So I designed a tilting basket. The basket has to move while, like, to allow filling the tubes and draining the tubes. So that it was necessary that we fill and drain. Otherwise, we will never clean the inside. It's not like a vapor system where vapor goes inside. The water system, it's water. If it's equal pressure at the inlet, water will not go. You will have an air pocket inside, huge air pocket that will not allow the tube to clean from the inside. So now we designed the tilting basket. Looks like that. This is the old style basket. It's inclined, and it's like that. It does. So we put our exchanger incline. No matter what we do, we cannot get rid of the oil from the ID, the tube, the inside wall of the tubing. So we designed this. It have a pivot, and it have a floater. We made a floater that when it's in water, it lifts it, and when you go outside, it goes outside the tank, basket goes down and drain. So it fills inside, it goes up, fills, and then we go out, it drains, it tilts the other way and drain the tube. So that movement, that's when we start getting a clean inside wall, tubing inside wall. And then the last phase, after we know that we fixed all those mechanical problems, the last phase was the program now have to change, because the new basket needed a program that is adapted to the functionality of the basket, which is when you go up, you have to wait until it drains, and then when it goes down, you have to give it time to fill. So we changed the program. The whole program has to be changed to adapt to the situation. So all this could have been avoided if we knew, if somebody else had the experience. Like now we had it. So anybody who will work on a QA system will definitely, if he see this, he will right away go to avoid those problems and time wasting. It took us almost 2 years to go through this, because when you change the oil, it's not easy. When you change the chemical, it's not easy. You have to do all the due diligence and customers involved, and it's a lot. So it takes time to do any change, and we had to do it. There is no go back to the TCE. It has to be done. So now so those are the two functionality that we focus on. The fin cleaning, it has its own time sheet. So it's when it goes up and down, and it has sonic fill time, which is it goes down, and then you start the sonic, and the sonic helps clean the fins, all those cavity inside in between the fin, the tiny cavity. There's a lot of oil in them, so that's the sonic break that out and clean it up pretty good. Then the agitation, it goes up and down. Also, we time that. We have a way to time that. And then the skimming and dwell time, which is we leave the part all the way down in the tank and we wait until the top of the tank is skimmed. Otherwise, if you take the part right away, it will take all that oil with it. And all the job you did was you pretty much zero all the cleaning you did before. So it need about 5 minutes to skim the oil, because we have a skimmer, we have a flow that skim the top. Now the tubing is a tilting process. It's the time you allow the tube to, you have to calculate that. We pretty much time it with a timer. How many seconds? It from 5 to 30 seconds. It depends on the size of the heat exchanger of the fins. All this have been done to start getting clean part. So the last phase was the program. Then when we changed the program, we start getting we start making good recipe and good cleaning. So now we have some advices, and again, this is just a tiny part of the what we did. For anyone who's choosing an aqueous system, so for any aqueous system, there are vital component, and based on our experience. So ultrasonics capability is a must. You can say, well, my part does not need, it's not fins, it's not tubing, it's just let's say just a block or rods, but you cannot imagine how much time you save actually with the sonic. Without sonic, you may leave it for 30 minutes or 20 minutes. With the sonic, a 5 minute will be good, and all the oil will be taken off any surface that the sonic get to. And usually, if it's wet, the sonic will get to. It doesn't need to be. If it's dry, it won't work. But it has to be wet. Any area you can wet with that water can get to, the sonic will clean. And then the turbojet. Turbojet is very important for it's a mechanical way to detach or remove oil from the surface, especially in between the fin. If you get a tiny flow with the hot heat and chemical heat, that will help remove the oil faster. And then the heat, of course. We work around between 140 and 155. That's that's the best temperature we work in, because every time you put a new part, the temperature goes down. Our system is 155. The temperature go to 149, 150. So that's good. We are within our spec. It's 50 plus minus 5 degrees. The detergent selection is critical for a successful process. As I mentioned, detergent is to be experimented. You cannot tell until you test it. It has to be compatible with the material, which is that's dealt with the company we buy the detergent from. They are the one who give us they guarantee that their product does not damage our material. They have our material, they know what we use, and they are the one who test it and tell us it's good to go, and we didn't have any problem with that. Beside the powder problem we had with the first chemical, beside that we didn't have any problem. It's very the cleaning is without any side effect for the material.
So excuse me. Ali, I just want to give you a bit of a time check. We have some really excellent questions in the chat that I'd love to get to. Would that be okay to move on to some questions?
Yeah, no problem. No problem. Yeah.
And for everyone in the meeting, Ali has put together an amazing amount of information in these slides, including that last slide, which is showing everything that Boyd learned through this process. So I really encourage you to take a look at the slides. I just put them in the chat, but I do want to make sure we address some of these questions. Pam, would you mind reading them out?
Yeah, no problem. And yeah, Ali, if you wouldn't mind just going back to the previous slide so people can kind of see that as we're talking about the questions that they had, because I agree. I think the things that you have learned over the 3-year process of really fine-tuning the recipe for your very specific needs are really helpful for the rest of us to kind of read through. So great job. Thank you. So we wanted to ask a couple of questions about the surfactants, and you went through the process where you started with one surfactant and then you decided that you needed to change it as part of your, I think, second phase of really fine tuning this. What is the surfactant that you ended up with? Can you tell us a little bit about the chemistry of that surfactant?
The brand name is Kaizen. I didn't know if I could put the name on so I didn't put any name, just because I didn't know if I could put the name of the chemical.
Yeah, that's the manufacturer. Do you know what the chemical makeup is of it? We can get to that. We can certainly let people know.
I can send you the when I get time, when
sure.
I can send you the information, which one we are using. It has been suggested by the manufacturer themselves. We just ask them we send them all the what we do and all the oil we are using and all that. And then based on that, they pick we didn't pick which one, but they picked the one that they think will work for our application, and they send us whatever they send us. We used it, and it worked fine. And it's if I can.
We can actually, if there's somebody from the TURI Lab who's familiar with what that is, you can pipe up. But let me ask you kind of a follow-up question, which is, so the surfactant itself, is it being used also to help with the penetration of the aqueous solution into the fins, as well as removing oils?
Okay, the surfactant itself is chemically speaking, is the main agent that encapsulate the oil and move it from the surface and release it in the mix. That's just a very simple explanation of how it works. Now, and also the other characteristic of the surfactant is it has to emulsify. I mean, it has to let the oil go, because if it keeps the oil, then you're gonna end up with the tank full of oil. So it has to take it from the pot and release it. That way, the oil can be skimmed. And all the surfactant works the same way, the same exact way. So no matter what surfactant you get, it's gonna work the same way. And they all, if you are using the compatible oil with that surfactant, it's gonna do the same thing. Is gonna take the oil from your pot, encapsulate it. Pretty much what it's gonna do is it's gonna play on the surface tension of the pot, get the oil. I think it's an electro type of encapsulation, and it catch the oil, take it from the pot, and then release it in the water. That way it can go to be skimmed.
Great.
So it doesn't hold it forever, but at the end, after 6-7 months, it's gonna be saturated. The chain of the surfactant will it's gonna have some oil in it that stay in it, and it's gonna be saturated and it's not gonna be anymore doing the job. So you have to know when to change the liquid and put a new one. So it is a process, to change.
Absolutely. And the next stage that you went through, phase that you went through, is to look upstream at what is the oil that you're using. And I really just wanted to point out that is classic toxic use reduction planning. Like, let's look upstream and see if we can understand why we're using the chemicals that we're using, and does that give us some additional insight into ways to be more efficient and to be able to reduce our use of toxic chemicals. So I wanted to point that out because I love that that process. And whenever we're looking for how do we change from the use of a highly toxic chemical like TCE to something like aqueous, what we're hearing is just how challenging that is. It's not a given, but going through these steps of really looking at what is a different solution we can use, how can we change that chemistry, can we change the reason for having that chemistry to make it easier. That's all part of that process. So I really love that. One of the questions that was asked was whether or not you need to add some sort of an anti-corrosion coating or process after you've done the cleaning, because this is an aqueous process. Do you now have to add some sort of anti-corrosion treatment?
We did not have to put any additive. It was at some point with the first chemical. That's something I didn't actually mention, but it's a good question because I forgot to mention that. The first chemical also, beside the powder, we have had some kind of a discoloration with the galvanized plate. We use some galvanized plate on our heat exchanger. The edges where the steel part, when the cut is made, that edge get discolorated. Somehow the mixture, chemical, temperature, water, created some coating, some yellowish gold coating. We thought it was deposits from copper. Then we analyzed the liquid. We sent it to a lab, see if there is any copper powder in the liquid. They say there is no copper. So we could not actually define what kind of reaction is happening that coated that just it's not the zinc, it's the iron side of it, that whatever is where the cut is made. So that's one of the other reasons. Also, we changed the chemical. I forgot to mention it, the powder and the discoloration. We knew that chemical has some agent or component that is reacting with either the zinc or the steel plate that is coated. So yes, that's the second thing. And but I never thought about adding any additive because I knew it's going to complicate my my process more. Unless you know what you're doing, I didn't want. And no one that we consulted actually suggested that. So yes, I didn't go to that.
It's okay. Thank you so much, Ali. And we have probably other questions, but I wanted to let Agnes wrap up. And I know that we also had something about OTA you wanted to share. So thank you again, Ali.
You're welcome.
Yes, thank you. In our last minute together, I just wanted to say thank you to Ali and to Nick for their immense generosity in presenting and sharing their lessons learned. One of our presenters today was unfortunately out sick. They were presenting from the Office of Technical Assistance and Technology. I do want to let you know that is a service that's available to Massachusetts companies. It's confidential technical assistance. If Pam, you could throw the link to their website in the chat, that would be amazing. And for those of you who are looking to use this webinar to get CEUs, remember that you have to complete the survey that we'll be emailing to you all over the next few days. If we could get a virtual round of applause for our wonderful speakers, Ali, Nick, and Jason, we really appreciate it.
Thank you very much. Yeah.
Have a wonderful afternoon, everybody. Thank you so much.
Yep. Thank you very much. I appreciate. Have a good one.
Thank you.
Great
Bye,
job, everybody.
everyone.
Thanks.
Thanks.
Thanks so much, everyone. Have a great afternoon.
You too.
Thanks,
Thank
Jill.
you.
Bye.
Bye. Take it easy.